You have already learned that the first derivative of a function can be interpreted as the slope of a tangent line to the curve. But how do we find the equation of the tangent line given the point of tangency and the equation of the curve? First, we recall the point-slope form of the equation of a line. It's written as y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, where m is the slope of the line, and x sub 1 and y sub 1 are the coordinates of the point P on the line. Okay, point on the line. Alright. So to find the equation of the tangent line, we'll be using this point-slope form. Alright, but what is a normal line? A normal line is a line perpendicular to the tangent line at the point of tangency. Let me just write that down. Alright, say for example, we are being asked to find the equations of the tangent and normal lines to a given curve at a specific point of tangency. So in this example, we are given a specific curve, y equals 3x squared minus 2x plus 1, and a specific point of tangency. First, we have to make sure that the point of tangency, that the given point is a point on the given curve. Okay, so just substitute the x and y coordinates. If it satisfies the equation of the function, then it means that the given point is a point on the curve. So if x is equal to 0 and y is equal to 1, does it satisfy our equation? Does the point satisfy our equation? So y is 1, 3 times 0 squared minus 2 times 0 plus 1. Okay, so 1 is equal to 1. So we have satisfied the equation. Therefore, 0.01 is at the given curve. Now, what do we need to find? Graphically, how do we draw this? How do we have this? What will we have if we draw this? So graphically, we'll have a parabola opening upward. So this is the graph of the given function. Now the point of tangency is here. So it's a parabola. This is the point with coordinates 0, 1. Okay. Now the tangent line to that curve at the given point of tangency would look like this. So it will touch the curve at the point 0, 1. Okay. So this is the tangent line. And then since the normal line is perpendicular to the tangent line through the point of tangency, so the yellow line is our normal line. So what we're being asked to find here in the problem are the equations of the tangent and the normal lines. Okay, so these two are perpendicular to each other. Alright, so we already know that if we differentiate the function y equals 3x squared minus 2x plus 1, we'll get the first derivative can be interpreted as the slope of all the tangent lines to the curve. So in this function, y prime is equal to 6x minus 2. Okay, now if we want to get the slope of this specific tangent line that we have in the graph, we'll just have to substitute the x coordinate of the point of tangency for x in y prime. So y prime is equal to 6 times 0 minus 2 at that point. So it's equal to negative 2. So this is the slope m of the tangent line. Okay, now to find the equation of the tangent line, we'll have to use the point-slope form of the equation of a line. So that's y minus y sub 1 equals the slope of the tangent line times x minus x sub 1. So substituting the point of tangency in this point-slope form and the slope of the tangent line, will have y minus 1 equals negative 2 times the quantity x minus 0. Okay, these are the coordinates of the point of tangency given in the problem. Okay, just simplifying this, we'll have y minus 1 equals negative 2x. Now, writing this in general form, so we'll just have to transpose everything on one side of the equation. So transposing negative 2x to the left, will have positive 2x plus y minus 1 equals 0. So here we have the equation of the tangent line. Okay. Now, we'll also be using the point slope form of the equation of a line to find the equation of the normal line, but we need to find the slope of the normal line first. Since the normal line is perpendicular to the tangent line, its slope, so the slope of the normal line will just be the negative reciprocal of the slope of the tangent line. So therefore, if the slope of the tangent line is negative 2, the slope of the normal line will just be the negative of 1 over negative 2. Okay, and that is equal to positive 1/2. So they are just the relationship between the two slopes. They are just the negative reciprocal of each other. Alright? So for the equation of the normal line, we'll use y minus y sub 1 equals the slope of the normal line times x minus x sub 1. Since this point with coordinates 0, 1 is a point on the tangent line and at the same time a point on the normal line. Okay, so we can use this point also to find the equation of the normal line. So it's y minus 1 equals the slope of the normal line, which is 1/2, times x minus 0. Okay, simplifying this, will have y minus 1 equals 1/2 of x. I don't want to be working with fractions, so let me just multiply everything by 2, and we'll have 2y minus 2 equals x. So I want x to be positive, so instead of transposing x to the left, I would transpose 2y minus 2 to the right and have x minus 2y plus 2 equals 0. And this is the equation of the normal line. Okay, I want you to write the equation always in general form, and the general form is written always like this. So look at this. This is the general form. It's in the form ax plus by plus c equals 0, where a, b, and c are real numbers. Right? So this is the equation of the normal line at the bottom. So again, to find the equations of the tangent and normal lines to the curve, what you have to do is get the first derivative of the given function, okay, the first derivative of the curve, and then from there you'll get the slope of the tangent line, and then find the equation of the tangent line through the point slope form of the equation of a line, and then get the slope of the normal line using the negative reciprocal of the slope of the tangent line, and then using the point slope form again to get the equation of the normal line. So example number 2, find the equations of the tangent and normal lines to the curve f of x equals x cubed minus 3x squared at the point 1 with coordinates 1, negative 2. Right, so let's start with the tangent line. Okay, so f prime of x equals 3x squared minus 6x. So to find the slope of the tangent line at the point 1, negative 2, we find f prime at x equals 1. So that's 3 times 1 squared minus 6 times 1. We get 3 minus 6, we get negative 3. This is the slope of the tangent line. Right. So to find the equation of the tangent line, we use the point slope form of the equation of a line. So tangent line times x minus x sub 1. Just substitute the coordinates of the point of tangency and the slope of the tangent line. So y minus y sub 1, in the given point, y sub 1 is negative 2, equals the slope of the tangent line, negative 3 times x minus x sub 1. In the given point of tangency, x sub 1 is 1. So just remove the grouping symbols on the right side, simplify the equation, and write it in general form. So the left side is y plus 2 when simplified, and the right side, upon removing the grouping symbols, will give us negative 3x plus 3. So just transpose everything to the left and we'll get 3x plus y. Now upon transposing positive 3 to the left and combining it with 2, we'll have negative 1. Okay, equals 0. This is the general form of the equation of the tangent line. Now let's go to the normal line. What is the slope of the normal line? The slope of the normal line is negative 1 over the slope of the tangent line, negative 3. So it's positive 1/3. Now for the equation of the normal line, you use the point slope form again of the equation of a line, but this time use the slope of the normal line Okay, so we still use the point of tangency with coordinates 1, negative 2. So 1 y minus negative 2 equals 1/3 times x minus 1. So it's y plus 2 equals 1/3 x minus 1/3. So just remove the denominator by multiplying both sides of the equation by 3, and we'll get 3y plus 6 equals x minus 1. Then transpose 3x plus 6 to the right so that x will still be positive, and we'll get x minus 3y. Transposing 6 to the right, we'll have negative 6. So combining it with negative 1, we'll have negative 7 equals 0. Okay, this is the general form of the equation of the normal line. Now, example number 3 involves an implicit function. So we'll just need to find, again, the equations of tangent and normal lines to the given curve, okay, at the point 3, 2. Okay, we just have to make sure that 3, 2 is on the curve, okay, and it is in this case. So first we find y prime. Using implicit differentiation, we find y prime. Okay, so we differentiate x squared plus 2xy minus 3y squared equals 9 with respect to x. And we'll get 2x, okay, plus, so for the second term, we need to use product rule for the derivative of xy. So it's xy prime plus y prime, okay, minus 3, no, the derivative of 3y squared with respect to x is 6y y prime equals 0. And then remove the grouping symbols. We'll get 2x plus 2xy prime plus 2y minus 6y y prime. We are solving for y prime here. So combine like terms with y prime. So I'll just have to transpose this term and this term to the right. And we'll just have 2x plus 2y on the left side of the equation. And then positive 6y y prime minus 2x y prime. And then factor out y prime from both terms on the right side of the equation, because we are solving for it. So y prime times the quantity 6y minus 2x. And then divide both sides of the equation by 6y minus 2x. 6y minus 2x. And we'll get y prime equals, we can factor out 2 from the numerator and the denominator. Okay, so 2 times the quantity x plus y over 2 times 3y minus x. So we can just divide 2 by itself and get y prime in simplified form, and it's x plus y over 3y minus x. Okay, so now if we substitute the x and y coordinates of the given point, okay, which is the point of tangency, so we'll have y prime, the value of y prime at that specific point, and that would be the slope of the tangent line to the curve. Okay, so y prime at x equals 3 and y equals 2. So over 3 times y, where y is 2, minus x, where x is 3. So it's equal to 5 over 3 times 2 is 6 minus 3, so 3. So this is the slope of the tangent line. Alright. So for the equation of the tangent line, y minus y sub 1 equals the slope of the tangent line times the quantity x minus x sub 1. Okay, y minus y sub 1 is 2 in the given point, equals the slope of the tangent line 5/3 times x minus x sub 1, which is the x coordinate of the point of tangency. Okay, just multiply both sides by 3, so that we'll not be working with fractions anymore, and we'll get 3y minus 6 equals 5 times the quantity x minus 3. So just remove the grouping symbols on the right side, and we'll get 3y minus 6 equals 5x minus 15. And then transpose 3y minus 6 to the right, so that 5x will still be positive. So 5x minus 3y. And then negative 6 will be positive 6 when transposed to the right. Combining with negative 15, we get negative 9. So this is the equation of the tangent line. Okay, the L for tangent line. And then for the equation of the normal line, we'll just have to solve for the slope of the normal line first. So the slope of the normal line is negative 1 over the slope of the tangent line, so 5/3. Okay, when we simplify this, we'll get negative 3/5. Okay, so for the equation of the normal line, we use the same form of the equation. So this time we use the slope of the normal line times x minus x sub 1. Y sub 1 and x sub 1 will still be the same. So it's y minus 2 equals negative 3/5 times x minus 3. Okay, so multiply both sides of the equation by 5. And so we'll get 5y minus 10 equals negative 3 times x minus 3. Again, remove the grouping symbols on the right side of the equation, and we'll get 5y minus 10 equals negative 3x plus 9. This time, I'll transpose negative 3x plus 9 to the left so that 3x would be positive. Okay, and then we'll have 3x plus 5y. Okay, transposing positive 9 to the left, it will become negative 9. Combining it with negative 10, we'll have negative 19 as a constant. So equals 0. This is the equation of the normal line.